Ever wondered how the ground beneath us, so solid and dependable, can suddenly shake and tremble, causing such destruction? Or how a tranquil ocean can turn into a monstrous wave, swallowing everything in its path? These are questions that have baffled mankind for centuries. The power of nature is inexplicable and awe-inspiring. It's in these moments of sheer force, when the earth quakes and the sea roars, that we truly realize the magnitude of nature's capacity. Earthquakes and tsunamis, two of the most devastating natural disasters, have the potential to reshape landscapes and lives in mere moments. They spark curiosity, fear, and a deep respect for the forces at play beneath the surface of our planet. From the rumbling depths of the Earth's crust to the vast expanse of the ocean, there's a lot to unravel. So buckle up as we journey into the heart of our planet and the depths of the ocean. Today we delve into the depths of the Earth and the ocean to understand how earthquakes and tsunamis occur. Imagine the Earth as a giant jigsaw puzzle, with pieces constantly moving and shifting. These pieces, known as tectonic plates, hold the key to understanding earthquakes. Our planet's surface is divided into several large and a few smaller segments termed as tectonic plates. They're like rafts floating on the semi-fluid layer beneath, called the asthenosphere. Now, these plates don't just lazily float around. They're constantly moving, albeit at a pace slower than your hair grows. But when these plates interact with each other, that's when things get interesting. Where two plates meet is called a fault line, and there are three types of interactions that can occur. Plates can move apart, which is called diverging. They can slide past each other, termed as transforming, or they can move towards each other, known as converging. It's this movement that causes earthquakes. When plates converge or diverge, the stress builds up until it's too much for the rocks to handle. They snap, releasing energy in the form of seismic waves, which travel through the Earth. These seismic waves are what we feel as an earthquake. But not all earthquakes are the result of tectonic activity. There are four main types of earthquakes: tectonic, volcanic, collapse, and explosion. Tectonic earthquakes are the most common, caused by the movement of tectonic plates. Volcanic earthquakes are related to volcanic activity. Collapse earthquakes result from caverns collapsing or similar subsurface implosions. Finally, explosion earthquakes are the result of the explosion of nuclear and chemical devices. So, while the term earthquake might evoke images of the ground splitting apart, like in a Hollywood movie, it's usually more subtle than that. It's the result of the Earth's crust behaving like a complex jigsaw puzzle, with pieces constantly moving and interacting. So, the next time the ground shakes, remember it's the result of tectonic plates playing a game of push and pull deep beneath the surface. Now, moving from the solid ground to the restless sea, let's talk about tsunamis. These are not merely big waves, but a series of waves caused by a large and sudden displacement of water. Imagine a vast stretch of water, seemingly calm and tranquil. Then, deep below the surface, an event occurs. An underwater earthquake, a volcanic eruption, or even a landslide. This event disrupts the equilibrium, displacing a colossal amount of water. This displacement is what sparks the birth of a tsunami. Underwater earthquakes are the most common cause of tsunamis. When tectonic plates on the ocean floor shift abruptly, they displace water above, creating waves that ripple across the ocean. Similarly, volcanic eruptions beneath the sea can also trigger tsunamis by displacing water with the force of their explosion. Landslides, whether they occur underwater or if a massive amount of land suddenly collapses into the sea, can also displace enough water to create these gigantic waves. But what makes tsunamis truly terrifying is their speed. In the deep ocean, tsunami waves can travel at incredible speeds, often as fast as a commercial jet. This speed, combined with the vast distances they can cover, makes tsunamis a threat to coastal regions far from the initial disturbance. As these waves travel, they may not be noticeable in the open ocean, but as they approach the shore, the shallow water slows them down. The wave at the back, still moving at high speed, catches up to the front, causing the wave to grow dramatically in height. This is when a tsunami becomes a towering wall of water, capable of causing immense destruction on impact. So, a tsunami is not merely a big wave. It's a series of waves born from a violent disturbance, traveling at high speed across the ocean, only to build up into a towering wall of water as it nears the shore. So, a tsunami is essentially the ocean displaying its incredible power, triggered by disturbances deep within its waters or beneath the ocean floor.